So in this video, we are going to discuss grouped frequency distribution tables. Basically, what happens is that for frequency distributions like we did in the previous one, where we're talking about the number of pets and we only had to deal with the numbers 0 through 6, it was very easy to make a basic distribution table. Sometimes though, when we deal with a lot of information that has a wide variety, maybe it goes from 0 to 50, we don't want to have a distribution table that has 50 rows in it. We want to shorten that up. So we do this by grouping the data into groups or classes. Think about when you fill out information about yourself, and a lot of times they ask you your age and it's always grouped into intervals like 18 to 25. That's kind of what you're doing with a grouped frequency table, is you're grouping those intervals so that you can kind of shorten the amount of data. So let's talk about the guidelines to grouped frequencies. Number one, you should have somewhere about 10 classes. We try to stay below 10. It doesn't have to be exactly 10. Sometimes you can have 7 or 9 or 8, but 10 is kind of what you shoot for. The width of each of your intervals should be relatively simple number. We kind of stick with 2, 5, 10, or 20. 2, 5, 10, 20 is a little big, but if you have a lot of data that's very widely spread, I can see where you would use the 20, but most of the time 2, 5, and 10 are usually our widths that we're going to go with. The lower limit of each interval should be divisible by the width. So that means that if you choose 2, your lower limit should always be a multiple of 2. The same thing if we do 5, your lower limit should always be a multiple of 5. And all classes should have the same width. It's very, very important when we talk about group frequency tables. We want everything to be consistent. So if we choose the width of 5, that means every single interval should have a width of 5. Okay, so now we're going to find the range of the data by subtracting the high minus the low value. So we're going to find the highest value and the lowest value, and we're going to subtract them. And then we're going to divide by those range possibilities, that 2, 5, and 10, etc., to determine which one will give us closest to the number 10 for our number of classes. So for example, I have this company, Syscon, is a phone answering service. The following data are their number of cells per day reported by the company last month. So we have this wonderful amount of information. So what we need to find is the highest number of calls per day and the lowest number of calls per day for that month. So if you look through the data, hopefully you find the 79. That is our highest. And then our lowest is going to be 11. Now there's multiple 11s in here. That doesn't really matter. I just need to know the lowest. So I'm going to start with the range. The range is 79 minus 11, which is going to be 68. And then what we're going to do is we're going to take and divide that 68 by each one of those numbers that we talked about for the widths. So if I divide 68 by 2, that's 34. That is way too many groups. Remember, I want to stay close to 10 as I possibly can. So if I take 68 and divide it by 5, that gets me around 14. Notice I'm not doing any decimals here. I don't really care about the decimals. I really care about the whole number. And that's a little too big as well. I'm rounding up, by the way. So if I do 68 divided by 10, it really would be 6.8, but we're going to round it up to 7. We go, oh, that's okay. We can do 7. Remember, it doesn't actually have to be the number 10 as far as the number of classes you have. It just has to be around 10. So 7 is a good number of classes. So now let's talk about how we actually put this together. So we're going to create the intervals. Since the width is going to be 10, our lowest value needs to be divisible by 10. Now remember, our lowest data value that we had was 11. So we need a value smaller than 11 that is still divisible by 10. So that's going to be from 10 to 19. Notice it didn't go to 20 because remember, 20 needs to be the start of my next interval, because my next interval, the lowest value, has to be divisible by 10. So that's why my interval stops at 19, and my second interval is going to start at 20. Okay, so let's look at this. Our first interval is going to go from 10 to 19. Our second interval is going to go from 20 to 29. Our third interval will go from 30 to 39, then 40 to 49, 50 to 59, 60 to 69, and 70 to 79. Now I stopped at 79 because if you remember, my highest value in my chart was 79, so I don't need to go up to the next interval, which would be 80 to 89, because I don't have any data values that would go into that interval. It would just be a 0. So I'm going to stop at 79 because that is the highest value I have in my data set. Notice that if I subtract 20 minus 10, that's going to give me that 10. Now when you talk about your width of your interval, you're always talking about subtracting the low of one class from the low of the previous class. So 20 minus 10 gives me 10. If I came down here and I did 50 minus 40, that would also give me 10. That's how I see the actual width. Don't subtract these guys within a class. You actually subtract the lows between classes right there together. Okay, so now let's do the fun part. We are going to do our frequency table. So what we want to do is we want to find every number in our data set that is between 10 and 19. So if we come over here to our data set, we'll look at all the numbers between 10 and 19. I have 6 of them. So we have 6 numbers that fit between 10 and 19. We do the same thing for 20 to 29. We have 8 numbers that are between 20 and 29. And we just keep on going the same way. So we have for 30 to 39, we have 5 numbers. For 40 to 49, we have 4 numbers. For 50 to 59, we have 3. For 60 to 69, we have 5. And our last set from 70 to 79, we have 4. Okay, at this point, we should have all of our numbers. So if we look at this, there are 35 numbers within our data set. If we were to add up our frequency column here, this should add up to 35. So we know we've talked about every one of these. Now here on this, I'm not marking them out. If I were doing this at home, I would be marking through each of the numbers I've counted. That helps me just keep track of what I have and have not counted as far as my frequency distribution goes. So now, so you can see right here, again, should sum up to 35, which is the number of data points we have. So now let's talk about the rest of the things that we talked about in our previous 2 videos. So just because this is a grouped distribution table doesn't mean we can't still find the percentile and the percentage and the cumulative frequency and the cumulative percentage. So let's start off with the percentile. Remember, we're going to take our frequency and divide it by the number of data points, in this case 35. So we're going to start off here. We've got 6 divided by 35, which gives us 0.17. 8 divided by 35, 0.23. 5 divided by 35, which gives us 0.14. 4 divided by 35 gives us 0.11. 3 divided by 35 gives us 0.09. Again, 5 divided by 35, 0.14, and lastly 4 divided by 35, which gives us 0.11 again, or 0.11. And then we're going to take those percentiles, and we're going to multiply them by 100%. So we're going to multiply that, and we get 17% for 10 through 19, 23% for 20 through 29, 14% are between 30 and 39, 11% between 40 and 49, 9% between 50 and 59, 14% between 60 and 69, and 11% between 70 and 79. So now let's figure out that cumulative frequency. Remember, that's where we're adding up the frequencies as we go from the lowest to the highest. So starting off with 6 in our first group. Then we're going to take that 6 and add it to 8. So we have 14 that are in groups or classes 1 and 2, which is our 20 below 20, or 29, excuse me. And then 14 plus 5 would give us 19. So that means we have 19 data points below 39. Our next group, we have 19 plus 4, that's 23. That would be 23 data points below 49. And we continue on this way. 23 plus 3 would give us 26. 26 plus 5 would give us 31. And lastly, 31 plus 4 gives us 35. Remember, for our cumulative frequency, it should always add up to the number of data points that we have, in this case 35. And then our last one, doing our cumulative percentages. Again, taking that cumulative frequency, dividing it by 35, and multiplying it by 100. And you can see we have 17%, 40%, 54%, 66%, 74, 89, and 100%. So if I wanted to find out what percent, or what number or percentile 89% of my data fell below, I would notice here that my 89th percentile is right here. 89% of my data falls below this 69, but remember, I'm not going to use the number 69. I'm going to use the real limit between 69 and 70, which is the value halfway between 69 and 70, which would be 69.5. So 69.5 of my data falls below, and that is the 89th percentile. I hope that this helped you understand calculating and finding a distribution that is grouped. If you have any questions about how to do that, please make sure to email me, and I would be more than willing to do another example for you. Have a great day.